Welcome everybody to lesson 13. We are going to revisit the idea of exponents. Now, exponents, yes, they matter in real life. They have to do with real situations. For example, they come up in scientific notation, they come up in computer science, they come up in financial growth, compound interest, they come up in measurement conversions. So here, we're just going to take a think back, and we're going to think back to why they matter. There below are some examples that I listed. So, why do exponents matter? Do they even exist in real life? The answer is yes. Here are some examples where exponent laws are used. The example at the bottom: if a file doubles in size every day, here's how you would show that scenario using exponents. 2 to the power of 5 is 32. It's a short, concise way to show repeated multiplication. And that's what exponents are, right? Exponents are just showing repeated multiplication. So that shows us it is 2 times 2 times 2 times 2 times 2. Who wants to write that out when you could just write 2 to the power of 5? And you get the same answer. So the file will become 32 times larger. Let's make a note actually at the bottom here. And we are going to write exponents are just repeated multiplication. Just so we remember. So on that note of repeated multiplication, we're just going to simplify these questions using repeated multiplication. 2 to the power of 3 times 2 to the power of 2. Let's show that. So 2 to the power of 3. 2 times 2 times 2. I need 3 2s. 1, 2, 3. Okay? Times 2 to the power of 2, 2 2s. 2 times 2. That's what that is. How many 2s do we have all together here? Let's count. 1, 2, 3, 4, 5. 5 altogether. We can show that. 2 to the power of 5. At the bottom here, we have a division. 5 to the power of 4 and 5 to the power of 2. Let's show that in repeated multiplication first. 5 to the power of 4. So we need 4 5s. 5. Okay. Divided by, and then 5 to the power of 2. So this one we need 2 5s. Here, we're going to cancel. Here, we're going to cancel 2 of these 5s. That leaves us with 5 to the power of 2. Now, to write out this repeated multiplication, we're doing this just to give us a visual for when we're going to talk about the laws. What did we notice about the bases? So the bases, what did we notice? We noticed they're the same. In example 1, both bases are 2, the big numbers. The big numbers attached to the exponents is the base. Both bases are 2. It was the same. And in number 2, both bases were number 5. The big number was number 5. It was the same. They are the same. And what happened to the exponents? Let's take a look. In number 1, we ended up with the exponent 5 when we originally had 3 and 2. So what happened? We notice that 3 plus 2 is 5. The exponents got added. When we multiplied, exponents got added together. And now let's look at number 2. When we were looking at division, we had a 4 and a 2, and we ended up with 2. What did we notice? 4 take away 2 is 2. When we were dividing, the exponents got subtracted. This brings us to our rules. We will be reviewing 3 rules. We're going to be reviewing multiplying, dividing, and powers. So, multiplying powers, multiplying exponents with the same bases. Here's our example at the top there. A to the power of m. So these are just random letters, but it's to give us a visual of the idea. So a to the power of m, now multiplication, that's what we're talking about here, times a to the power of n. Let's say that's a different exponent, equals m plus n. So this is showing us when we multiply and the bases are the same, we add the exponents. This is the rule. Add the exponents when multiplying powers with the same base. A and A are the same base. So we add the exponents when we multiply. Let's look at an example with numbers. We have 3 to the power of 2 and 3 to the power of 4, and we see it's multiplication. We know then the bases are the same. We know our rule is to add the exponents together. We can add our exponents 2 plus 4, and that will give us 3 to the power of 6. Why does this work? If we write it out in repeated multiplication, 3 to the power of 2 is 3 times 3. 3 to the power of 4 is 3 times 3 times 3 times 3. How many 3s do we have all together? We have 6. We have 3 times 3 times 3 times 3, 2, 3, 4. That is what we have when we put them all together. Do you notice that multiplying them together gives 6 3s? So the answer makes sense, being 3 to the power of 6. We add because we're combining repeated factors. We're combining all that repeated multiplication. So we add it together. Our next rule, dividing. So again, we have our letters. We're just taking a visual of what it would be. A and A, we're using the same base. A to the power of m divided by A to the power of n. We know those are the same bases, and it's a division question. We know we can subtract our exponents. So we will put A, keep A, and then take away the exponents, m take away n. We will subtract the exponents when dividing with the same base. Let's look at an example here. We have 5 to the power of 6 divided by 5 to the power of 2. Now, that has the same base of 5 and 5. So we know we can use our exponent rule and subtract our exponents. So we can do 6 take away 2. That leaves us with 5 to the power of 4. Now, why does this work? When we write it out in repeated multiplication, we have 5 to the power of 6. So 5 times 5 times 5 times 5 times 5. And then we have 5 to the power of 2, 5 times 5. Now, when we combine them all together and then we cancel out 2 of those 5s, so we take these away, right? We cancel those out. We are left with 4. We subtract because we are removing the repeated factors. We're removing that repeated multiplication. Supposed to have another 5 in there. Add another 5 on there, guys. All right. Now, this is our last rule, power of a power rule. So we've seen this kind of setup before with exponents. Again, we are just looking here to get a visual of what it would be with numbers. A to the power of m, bracket, and then it has another little exponent outside the bracket. So when we see that setup and it's the same base, we know we can just multiply the exponents. So this is called the power of a power rule. Multiply the exponents together. Simple, easy. If you see this setup of any number and it's asking you to work with the exponents, we know multiply them together. So this is our question. 2 to the power of 3, and then it has a little to the power of 2 on the outside of the bracket. When you see that setup, using your power rule, we know, take those exponents, multiply them together. That will give you 2 to the power of 6. Now, why does this work? If we write it out in repeated multiplication again, this is asking us to do 2 times 2 times 2, so 2 to the power of 3, 2 times. So it's asking us to do it 2 times 2 times 2 in one bracket, and then it's asking us to double that. Another set of brackets that has 2 times 2 times 2. If we count how many 2's we have all together, 1, 2, 3, 4, 5, 6. So that gives us 6 2's all together. And that's why this works. Let's practice. So the first one there, it's asking us to multiply. Multiply. When we think back to our exponent rules, we have to think about what was our rule for multiplication. We can even just go back and look. Multiplication. Here we are. Multiplying powers with the same base. Okay, we think addition. Addition of exponents. So here we have x to the power of 4 plus x to the power of 3. Let's add that. X to the power of 4 plus 3. 4 plus 3 is 7. X to the power of 7 is the answer. Simple, right? Now, number 2, 7 to the power of 2 times 7 to the power of 5. The bases are the same. The big numbers are the same. We know, okay, we can add those exponents. Let's do that. 7, and let's add our exponents. 2 plus 5. It'll give us 7 to the power of 7. And that is our answer. Now we have here a to the power of 6 times a. Now we know, remember, a really is a to the power of 1. So we can rewrite that. A to the power of 6 times, just to give us a better visual. The basis is the same. Even though it's not a number, it's the same. It's an a. So let's leave a. 6 plus 1. A to the power of 7. And that's our answer. we don't really care about the base. We don't care if it's a letter or a number. As long as it's the same, we're keeping it. Now, division. Division, think opposite of multiplication. So for multiplication, we added our exponents. Division, we subtract our exponents if the bases are the same. Here we have y to the power of 8 and y to the power of 3. Y is both base, so it's the same. It's a letter, but we don't care that it's a letter. We're keeping it. Because it's division, we know our rule, subtract exponents. Let's do that. 8 take away 3 is 5. So our answer is y to the power of 5. And that's it. That's where you stop. That's your answer. 10 to the power of 5 divided by 10 to the power of 2. We see 10 is the base, and it's the same base. We know it's division. We know our rule for division is subtracting exponents. 10 and our exponents, let's subtract them. 5 take away 2. 5 take away 2 is 3. So we have end with 10 to the power of 3. And that's where we stop. That's our answer. Now we have B. Again, it's a letter. We don't care that it's a letter. We know that it's a base, and we know that it's division, so we know we're subtracting exponents. B with 9 take away 4, 9 take away 4. So B to the power of 5. Power of a power. So now remember, our next rule is when you see this kind of setup, what do? Let's look back. What was our rule? Power of a power rule. We are multiplying the exponents. Multiplying. Let's go down to our questions then. Power of a power, we think multiplying the exponents. Okay, let's do that. M, and then we have 3 times 2. 3 times 2 is 6. M to the power of 6. Done. Easy. That's our answer. 4 to the power of 2, and then to the power of 3. So we will write it like this. 4, and then we will multiply our exponents. 2 times 3. So then we will end with 4 to the power of 6. Done. Got our answer. At the end here, there are 2 common mistakes to avoid. So you only add exponents when you're multiplying. Okay, that's it. And the second one, you multiply exponents when it looks like this, the power of a power. You multiply exponents, not add. The common mistake is that you see that and you instinctually want to add them, but we have to remember that you only add exponents when you're actually multiplying 2 separate bases. So this is a power to a power that's different. So I want to just add a couple notes here. Multiply. Add. Exponents. Divide. Subtract. Exponents. Power of a power. Multiply exponents. And bases must be the same. If the bases are different, these rules do not apply. Different bases, rules do not apply. Okay, so you can go work on your student handout for this lesson, and I will see you next time. Great job.